Welcome back to another Algebra 2 lesson here today. Today we're going to be talking about graphs of functions. We're working on the FG.4 notes. This target is part of Unit 2, technically. We did take the Unit 2 test already, and so I'm kind of splitting this off a little bit. The purpose was mainly to shorten the length of your test, but also allow us to focus on a variety of functions in this target. So we're going to go through and we're going to complete the notes. This target is going to be reliant on definitions. So you don't see that a lot in Algebra 2. Like you have a lot of definitions in geometry and other classes. In Algebra 2, you don't often see a ton of definitions. But in this target, we're going to have quite a few. So we're going to go through the definitions to begin with, define each term, and then provide you examples on a graph, and then look at a couple of different graphs and redefine those terms with new examples. So let's get right away to our first definitions. Your packet may not follow exactly the order of the words, but they're all in there. We're going to start with domain and range because you guys are familiar with domain and range. So the domain is the set of all x values for a function. We should know this. And the range is the set of all y values for a function. So if I take a look at this function, I'm going to use kind of the path of the function, the arrows, to define the domain and the range. So the domain would be, again, all x values. So as I follow this function, we've got some arrows on the ends. This arrow is going up and to the right forever. This arrow over here on the left side is going up and to the left forever. So this function is going to go left forever and right forever on the x-axis. And so we would say that this has a domain of all real numbers. So there's a couple of different ways that you might see that written. We may write this in interval notation, where we would say that the x values go from negative infinity, the furthest to the left that they go, to positive infinity, the furthest to the right. We also may see this written as an inequality, where negative infinity is less than x, which is less than infinity. And we could potentially see this written as just all real numbers. So any of these would be an appropriate way to represent the domain for this function. The range, again, is all y values. So noticing by the arrows, this does go up forever. However, this function does not go down forever. The lowest point that it gets to, we can see on this graph right here, is at -6, -5. So the y value is the lowest y on this function, which is -5. So we may see this written in, again, a variety of different ways. If we write it in interval notation, this would be for y values. Sorry, I should have put the appropriate symbol in here. The exists within symbol. So this would be y value exists within. The lowest that it gets is -5 with a bracket because it is equal there to infinity. We could also write this in an inequality where y would then be greater than or equal to -5. So from -5 going up forever. Both of these ways are okay to represent that. So domain and range we should be familiar with. We found those with other functions already. And the domain for this function would be all real numbers. The range for this function would be greater than or equal to -5. The x and y intercepts. We've seen these before already this year, and you should be familiar with them as well. So the x-intercept would be any intersection that occurs on the x-axis. And then the y-intercept would be any intersection that occurs on the y-axis. We have also listed x-intercepts and y-intercepts in function notation. So in function notation, any intersection on the x-axis would be where f of x is equal to 0, or the y values are equal to 0. Any intersection on the y-axis would be f of 0, or where the x values are 0. So generally what we do here is we list the x values because we already know what the y values are going to be. So if I look at my graph, x-intercepts would be anywhere where the y values are 0 on the x-axis, and we can see we have two of those. So generally we write those as, we would write those out as what x is equal to. X would be equal to -8 or -3. We could also see that written as a point, so we could write that as 8, 0 or -3, 0. Let me go ahead and use the appropriate symbol for or here. If you don't use the symbol and just put a comma in there, that would be okay. I know what you mean. Now the the y-intercepts would be on the y-axis, and in this case there is only one. We generally list the y-coordinate here because we already know the x is 0, so this would be y equals 6. You could also write this as a point, 0, 6. So far all of these terms are nothing new. We're familiar with them. We should be able to locate those on the graph. Positive and negative intervals may be something that is new to you. Positive intervals and negative intervals, take a look at the value of y, or the value of f of x. So a positive interval would be any of the domain values, remember domain are x values, where f of x is greater than 0. So what we're looking for, and we're going to list intervals here, intervals where the y value, or f of x, is greater than 0. So if I take a look at this graphically, if I draw a line right here on the y-axis, the x-axis, anything above this blue line would be considered a positive interval, because this is where the y values are all positive. Anything on the blue line would be considered no value here for positive or even negative intervals. So this section over here, this part to the leftmost of this graph, this is a positive interval. Now this will go up forever and to the left forever. So this interval is going to start at, so x could be within -infinity to -8. So we are listing the x values here, the domain values. The x values where the y is positive. So at -8, its y value is 0. So I put a parenthesis around -8 because it is neither positive nor negative there. Now my next interval, all of this would dip under that x-axis, and so none of this would be a positive interval. We'll come back to that in a little bit. Once I hit this x-axis and I move above, now again I'm at a positive interval. So this positive interval is going to start at -3, and then it's going to carry on forever. It never goes back below the x-axis. The y values never continue to be, or never turn around to be negative values or 0, and so this would go on to infinity. So a positive interval are the x values where the y values are greater than 0. Now a negative interval, as you might assume, is the opposite of that. A negative interval would be anywhere where any x values that are going to lead to negative y values. So again, I'm going to kind of draw in this x-axis line. Anything below the x-axis is going to be a negative interval. And so we see we only have one portion here of this graph where it dips below the x-axis. So we're listing the x values that lead to negative y values. So it's going to start as soon as it crosses this point. Remember, at -8, the y value is 0, so that's not positive or negative. So it's going to start just on the other side of -8. So this is going to go from -8, and then it's going to continue. Let me trace through here. It's going to continue to be negative, 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 negative. And then when it gets back to the x-axis, it's no longer negative, so it stops being negative at -3 on the x. Now again, we're listing the x values that lead to negative y values. So this section right here is a negative interval because it's below the x-axis. It has negative y values. We list the x's that correspond with them. So positive and negative intervals determine if the graph is above or below the x-axis, essentially. We also have increasing and decreasing intervals. So an increasing interval would be any set of domain values, again looking at the x, that lead to increasing range values, looking at the y. Conversely to that, decreasing intervals would be any set of domain values that lead to decreasing range values. So basically what we're going to do here is we're going to look at the graph and we're going to figure out where the y values are increasing as we move left to right, or decreasing as we move left to right. So the focus here is we're moving left to right. So basically, if I trace this graph as I move left to right, am I going up or am I going down? Now the points, let's notice there's some points here labeled. These points where they turn around, like this point right here at -6, -5, is neither increasing nor decreasing. So that's going to kind of be the stopping point for our interval. So let's go through this graph left to right, and let's identify increasing and decreasing intervals. So again, this graph goes up forever in this direction. So as I move left to right, here, I'm coming down. So this would start as a decreasing interval. So I'm going to list this as starting from negative infinity. So this is going to start from negative infinity, and I'm coming, as I move left to right, I'm coming down, 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 and right here I turn around at -6. So we're listing the x values, the domain values there, so the end of that interval would be -6. As I pass -6 moving to the right, I start to increase. So this is going to be an increasing interval. So from -6, I'm moving up, 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 up. Keep going up all the way till I get to this point. So the y value would be 2. Sorry, the x value would be 2. So my first increasing interval goes from -6 to 2. Again, you kind of make sense of that. If we were like, think of this as like a roller coaster ride. If this is a roller coaster ride, this is going down, that's a decreasing interval. This is going up, that's an increasing interval. At 2, we turn around again, and now we start to come back down. So there's another decreasing interval. This one starts at 2, and so we follow it from 2, comes all the way down to this point. The x value there is 6, so from 2 to 6 on the x, we're decreasing. Then at that point 6, we turn around and we start moving up again. So we have a new increasing interval. It starts at 6, and then it goes up and continues to go up forever. So this increasing interval would go from 6 to infinity. So basically what we're looking here for is as we move left to right on the graph, are we moving up, are we going upwards, or are we going downwards? Now increasing and decreasing intervals also relate to our next term, which is called relative maximums and minimums. So a relative maximum is the point where an interval changes from increasing to decreasing. And a relative minimum is the opposite of that, a point where an interval changes from decreasing to increasing. So what we're looking for here are basically the hilltops and the bottoms of the valleys on this graph, or our turning points where we change direction from going down to going up. So let's follow this graph again from left to right. This is a decreasing interval, we already stated, and now right here at -6, -5, we turn around. This is a relative minimum. So it's the lowest point in that general area for that graph. Now, as I continue from left to right from -6 to -5, I'm increasing here. And at 2,7, I'm changing from increasing to decreasing. That's a relative maximum. Then I continue again. I'm going down. I'm decreasing here. At 6,2, I change from decreasing to increasing. So this one is also, let's say, and this is also a relative minimum. Let me use the symbol for and there. So essentially our turning points on our graphs are the relative maximums and relative minimums. Minimums would be the lowest point there, maximums the highest, and we can see that where the graph changed from increasing to decreasing or decreasing to increasing intervals. Now we can continue from that. There are absolute maximums and absolute minimums sometimes. The absolute maximum would be the absolute greatest y value that exists, or we could call it a point where the y value is the greatest. The absolute minimum would be the single point where the y value is the least. So sometimes these exist, sometimes they do not. Taking a look at our function, let's look first for an absolute minimum. So I want to find the lowest location on the graph, and that would be here, this turning point down here at the bottom. So this was a relative maximum, but it's also an a relative minimum, but it's also an absolute minimum because it's lower than any other point. So we could list this as a point, or we could list the y value there at that point. Now, absolute maximum, we're looking for a single point that's higher than anybody else, any other point. We need to be careful here. Most people would look here and say, okay, 2, 7, that point is higher than any other point. But remember these arrows right here. These arrows mean that this function will go up forever. It'll go up and it will never stop going up. So what that means is that there's no point that's going to be taller than or higher than any other point on this graph. The x values, or sorry, the y values will continue to go to infinity. They'll go up forever and ever. So there's no singular point that's higher than the rest. There is no absolute maximum. So not applicable, or D and E for does not exist would be our answer. So absolute maximum and absolute minimum points are going to potentially be relative maximums or relative minimums, but they also may not exist. We have probably a new definition for everybody here. This definition is our last one. It is in behavior. In behavior are, or is, the range values as the domain approaches positive and negative infinity. Or basically, what is the graph doing to the left? What is it doing to the right at the ends of the function? So how we tend to write this. Writing this is going to be some notation that's going to be new. Range values is what we're looking for, the y's. As the domain, the x's approach positive or negative infinity. So how we write this out is x is going to go to negative infinity and x is going to go to positive infinity. We want to write what the y's do at that location, or those locations. So x is always going to go towards the left. X is always going to go towards the right. We need to figure out what is y going to do based on that. So if I look at this graph, as x approaches negative infinity, so I can trace through this. X approaches negative infinity means leftmost on this graph. So here's my little cursor here. I'm following to the left, and the further and further I get left, I keep going up and up and up, and I never stop going up. So as x approaches negative infinity, y approaches positive infinity. It goes up forever in this case. So that is the leftmost portion of the graph. As x approaches positive infinity would be going the other direction, so I can trace through this. As I go to the furthest to the right, here's my cursor going up and up and up. It never stops. So y approaches positive infinity. So this end behavior is basically we're looking at the ends of the graph. What is the graph going to do to the left? What is the graph going to do to the right? So this notation again, x approaches negative infinity means going towards the left. Y approaches positive infinity means we're going up. X approaches positive infinity means I'm going to the right. And as I go to the right, y also approaches positive infinity, so I'm going up. Okay, so the notation here is probably new. Concept probably not so difficult. You can see that this graph is going up both directions. Now we have to correlate that to that written expression. And this is a good place to stop for part 1 in the notes. So we have each of the definitions down that we're going to use to take a look at and describe different parts of graphs, or different parts of graphs of functions, excuse me. We will continue on from here and take a look at a couple more examples and then a little bit of application of functions of graphs. Thank you guys for tuning in, and I will see you soon.